Yes, thank you for this introduction. Thanks everyone for sticking around until the bitter end here, and also thanks Tarmo and Margit and gentlemen at the back running the show so smoothly here. So this has been an excellent meeting with the excellent organizations. Thanks for that. Okay, so here I go then. The last presentation of the meeting, long-awaited moment. Yes, so I'll talk about the precipitates forming at the seafloor in the Gulf of Finland, but first I say something more general about the uniqueness of the Baltic Sea. And if we look at this figure here, which shows where various types of autogenic precipitates, this means that the minerals that form at the seafloor or in the shallow sediments occur in the Baltic Sea. These dark areas on this map, they're showing the positions of Landsort, Gotland, and Bornholm basins are the anoxic deeps of the Baltic Sea, where reduced iron and manganese minerals form. These are sulfides and carbonates. And in the more shallow areas, we have the precipitation of these oxo-hydroxide type of phases. And the Gulf of Finland is one of the hotspots when it comes to these oxide precipitates. If we zoom now in towards the central part of Gulf of Finland, around the Estonian island of Vaindlo, which is about 100 kilometers east from here, and then at the right-hand side we have the bathymetric image of the seafloor, the green and reddish colors showing the areas of the shallower waters, and the blue areas showing the areas of the deeper water. Then in this area of the Gulf of Finland, central Gulf of Finland, we see that the seafloor is highly variable. In the northern part, where we have this rough seafloor, this is where the bedrock, crystalline bedrock, exposing right at the seafloor. Whereas if we come further south, the seafloor gets more smoother. That's where there's a more sediment deposition. But again, there are these ridges and depositional areas closely spaced together. And on the left-hand side, we have this greenish map showing the distribution of these iron-manganese oxo-hydroxide precipitates that have been documented during previous mapping programs that the Estonian Geological Survey has been spearheading. So yes, so we see that there is a huge amount of concretions, huge amount of these manganese nodules in some areas, but the distribution is patchy, and they occur only in the areas where there is no modern deposition. So no modern deposition, so that the bedrock or the deposits that were deposited during the glacial times are exposed right at the seafloor. So, and if we zoom now in to this red square shown on the bathymetric image at the right, there we see a submarine ridge. The bathymetric image is again on the right-hand side, and this submarine ridge has a length about 3 kilometers and the width about half a kilometer. And if we look closely into this submarine ridge, then we see that there are these holes in it. So this is like a Swiss cheese on a seafloor. And these holes, this is because of there is some sort of fluid coming from below and generating these holes for us. And these are carved into these late glacial deposits that were accumulating in a basin some 13,000 years ago. And so what do we see within these depressions, what we call pockmarks, and around them we see these whitish, brownish microbial mats together with the seafloor precipitates. And if we take a sample from it, then what do we get? We get these various morphological types of crusts and nodules. Very beautiful materials for studying. So yes. I've impressed my wife with that. So, but if we have had chance to go down onto the seafloor and see what's really happening there, and how these microbial mats and the precipitates that are forming are interlinked. And so this is the collaboration with our Norwegian partners from NTNU. So you guys, this is the NTNU ROV that we brought here to Tallinn. in August, and we had the great privilege of using it and creating great information about the seafloor. So if I run that, and so that here we are within one of these pockmarks. So left-hand side we have these 2-meter escarpment of carved into the warped clays, and in front of this escarpment we have these beautiful microbial mats forming there, telling that there are some reducing fluids coming up, possibly rich in methane, giving rise to the mats of sulfur-oxidizing bacteria forming at the seafloor. So this is what we see within these pockmarks. So that beautiful features, nice vertical escarpments, excellent field geology you can do at the seafloor. But if we go a little bit away, so that's what we see is the seafloor covered by these precipitates. Nothing else, just a layer of precipitates. Tightly together. So there are various types. Some of them are more crust-looking, some of them are more like nodules. But yes, many areas of the central Gulf of Finland. That's what we have. Isn't that fun? So why do we have these pockmarks and concretions forming on the seafloor? So if I look at little bit deeper what is below the seafloor, and this is the seismic profiling done by the Estonian Geological Survey across the submarine ridge, a little bit west of the island of Vaindloo, and the upper panel shows the unfiltered raw data that are obtained by the seismic profiling, and the lower panel tells us about the interpretation of these seismic profiles. And the lower unit, this is the bedrock, this brownish-looking unit, this is a bedrock. In the middle of the ridge, we have a yellow unit on top of it. This might be another type of sedimentary rock, or could be glacial till. We don't quite know exactly. But then on top of it, there is this blue layer, which is about 10 meters thick. And this is the... Is there something wrong? No? Okay. Are you sure? Anyhow, so we have this 10-meter layer draping the pre-existing seafloor. When there is a topographic high, the blue unit makes also the high. When there is a topographic low, blue unit makes also a low. And this is a typical for the deposits that were depositing in a basin in front of the ice sheet. These are these so-called warped clays. Glacial lacustrine clays, so that this is the snapshot of the area of about 13,000 years ago, when in front of the ice, there was still ice in Finland, so that you guys, our Finnish colleagues, had a little bit colder times than us at that point of time. But here we had a big body of water, and then in this big body of water, these clays, warped clays, warped because they consist of the sandy layer and the clay layer. The sandy layer corresponding to the melting during the summer, and the clay layer corresponding to the more general melting throughout the years. So that these warped clays accumulated all over the Gulf of Finland and huge parts of also the other parts of the Baltic Basin, and put this 10-meter blanket to the seafloor. And this 10-meter blanket is really rich in clay, so that if we have some fluids coming from below, they are stuck. So they would try to find a way out and try to find the weaknesses, and then they migrate towards the topographic highs where they punch through. And that's how we form these pockmarks, which occur in many different places, but are really common on the topographic highs, where the warped clays are exposed there. Okay, so that we have some sort of fluid control mechanism, which is dictated to some extent by these warped clays, by 10 meters of the clays that are blanketing the basin. But where do these fluids come from? Well, if we look at this image here, and which is the product of the European Union program EMOTNET, and showing the various marine minerals in different parts of the Europe. I zoomed into the Baltic Sea with a focus on the Gulf of Finland. Then we see that the eastern part of the Gulf of Finland is really rich in these polymetallic nodules. That's where they occur in a huge abundance, really, eastern part. So what's the big deal about the eastern part of the Gulf of Finland? What's happening there? What is the geology? Is there some sort of geological control behind it? So if we now add the geological map here, so I'm sorry, this might be a little bit too much of the geological information. I did certainly something wrong.
Okay, I just wanted to move with you.
Oh, yes, I messed it up again. Okay. I don't know how this is going to go. Yes, so this is a geological map. The pink colors, they apply for the crystalline rocks of Finland, and as we come southward, we have the cover of sedimentary rocks on top of the crystalline basement. And this grayish-looking unit at the eastern part of Gulf of Finland, these are the sandstones of the Ediacaran period, about 550 million years ago. And these sandstones, they thicken eastwards and have their outcrop, not outcrop really, but subcrop in the eastern part of Gulf of Finland, in the very same area where these manganese oxide, where these nodules occur. So that could there be a link that these Ediacaran rocks, the porous Ediacaran rocks, which can carry a lot of fluids, could be the source of fluids that bring us the dissolved manganese into the marine environment, and then it gets reprecipitated on the seafloor. We don't know, but there is this geological coincidence. What do we want to figure out in a greater detail? But why there should be fluids in these Ediacaran rocks that want to leak out? Well, how do I do it? Yes, so this is there's another piece of geological information, geological cross sections from the Gulf of Finland southward, and then this yellow unit there on top of the pink rocks. This is this Ediacaran horizon, which overlaps in its subcropping area with the occurrence of these manganese nodules. So could this Ediacaran sandstone be leaking and give us all the fun that we have at the seafloor of Gulf of Finland? Well, it's kind of interesting, but if we also consider the recent, more recent geological history during the glacial times and deglaciation, then when we had the ice at its maximum 25,000 years ago, we had 1,500 meters of the ice on top of whatever substrate was here, and this was generated quite some extra loading for the underlying strata, and could generate in these aquifers extra pressures which were released then when the ice was taken away. So, and then the question is, do we have some indications when has the leakage been occurring, and how can we time constrain it? So, and this is when these concretions come in really handy. So this is one of the concentric concretions going layer by layer by layer. We want to really open their birth certificates. So we want to know when they were born and how long they were living. Well, we are working on these radiometric dating of these concretions, but we don't have the answers yet. But one of the answers could come from the stable isotopes. The stable isotopes, organic matter that are embedded during the precipitation period. And if we look at the graph at the right there, so that organic matter that was deposited in the Baltic Sea basin during the late glacial times is significantly different from the organic matter that deposits in a basin these days. So that yes, so that's a 2-3 promille difference. So that the late glacial deposits contain organic matter with values of -27, and whereas the modern organic matter is about -23 or even 23, 24, depending where we are in the Baltic. And if we look now in what kind of organic matter is embedded in the concretions, then we see that in some of the concretions, in the middle part, we have these -27 numbers. And these 27 numbers are then typical for the late glacial times, so that it might well happen that we had a pulse of the initial growth of these concretions already during the late glacial times. There was possibly quite some fluid movement then as a Baltic Sea ecosystem was trying to establish the equilibrium with a new situation of deglaciation, and then the precipitation continued a little bit later, or quite a bit later as well, as some of the concretions contain organic matter that is typical for the modern Baltic Sea. Anyhow, so there's still a lot to do, and we have this international team here and many students involved, and we have been putting in proposals for the different funding sources. The funding scheme Water for All that was mentioned yesterday is one of the targeted funding sources. But so what do we want to do? We really want to do the geological and hydraulic context of the nodule formation, what we want to get a handle upon. We want to know the sources of iron and manganese. We want to know the controls of precipitation. We want to know the timing and tempo associated microbial processes and consortia, their economic potential, and also what needs to be assessed is the environmental aspects that connect to the stability of nodules. And then I come to the last slide here, and this is the troublesome aspect. So that we have these beautiful seafloor features in the central Gulf of Finland, and we know that we have been discussing that there are these oil tankers parking in the middle of the Gulf of Finland, exactly where these beautiful seafloor phenomena are occurring. And it's not really know how they influence the seafloor. Of course, they are really doing the damage. There's no question about that, so that we can call it geovandalism. But there might be environmental consequences as well, as these iron-manganese precipitates on the seafloor. They are real sponges for the phosphate, they are sponges for the range of metals. And if the anchoring, the disturbance of the seafloor stirs up the seafloor, and these iron-manganese concretions happen to be in an environment where they become unstable and can be reductively dissolved, we may have the environmental problem on top of all the political issues as well. So that's what we want to kind of collaborate with across disciplines and as I said yesterday, work out the best ways to take care of and manage our unique resource, which is the Gulf of Finland.
Thank you very much. So, any questions? Pentti.
Well, thank you again. Very interesting presentation. We were studying iron-manganese in early 80s. It was a very hot topic when I was a student, actually. Yeah, but not in the Gulf of Finland, but somewhere outside south. But my question is, any idea about the economic value of this iron-manganese in Gulf of Finland? Is it any idea about, should I buy a boat and start getting them out? Or?
Well, when it comes to their economic value, and then if we put these concretions into the perspective of the deep sea mining, so that there are plans for mining these type of concretions in the Pacific and in the Indian Ocean and in these oceanic basins, these concretions have been growing over millions and millions and millions of years, whereas in the Baltic Sea we don't have this luxury. They were born when the ice retreated from the area, or they started to grow then. And in the deep sea concretions, the main catch is cobalt. The cobalt is really the economic resource that the companies are trying to get out. The cobalt concentration in the Baltic Sea nodules is relatively low, so the different scavenging mechanisms so that haven't really allowed the cobalt to be enriched in economic quantities. What Russians have done have tried to use them as a manganese resource, but these things need to be evaluated properly. So yes, I can't answer the questions. I'll write into the letter I sent to Santa, perhaps, yes. Some answers.
There's some other Arno Kotilainen will ask.
Thank you, Aivo, for a very interesting presentation. Dealing with those pockmarks, do you think so that those, as you said, been active since the declassiation all the time, or?
No, I think they are dead pockmarks and they are live pockmarks. So they are these beautiful active pockmarks which have these vertical walls, even negatively tilting walls, and then we see the band of microbial mats right at these walls, telling that something is pressing up from there. But then there are these pockmarks that have lost the steepness of their slopes, and then we don't see this kind of active microbial activity in them. So they are active ones and they are dead ones.
Okay, thanks.
Yeah.
Okay, other questions? At least now we learned that the best time of the Estonian history was that when the ice had already melted in Estonia and Finland was still under the ice.
Yeah, well, you are following it.
Yes.
Yeah. That's
Yes.
good. I didn't put you to sleep right away.
Yeah, no. Okay, thank you very much, Aivo. This was very nice presentation.
Thank you.